Our next example does have some trig functions. So, big deal, right? We just gotta draw it. And what's nice here is that they told us that x goes from 0 to pi. So I don't have to draw everything. I just want cosine of x from 0 to pi. So pi over 2, and let's say this is pi 1, right? So cosine of x, cosine of x is 1 at 0 and -1 at pi. So it'll be here, and it goes through 0 at pi over 2. So that looks more or less something like that. Close enough. Now, what happens with 1 minus cosine of x? Well, we know with our usual transformations, minus cosine of x, I just plop it over, and then I move it up 1. So that is going to look like this. Move it over, plop it over, move it up 1. So, and then they want this whole region, right? So notice that if they just said, I don't know what they would have to say, because it's not like it covers itself in any way, but they say x goes from 0 to pi. So that means they don't just want this little bit, but they want that little bit and this whole other bit. It's taking me a long time to draw, but this whole other bit, yeah, just like that, just like that. And so we have to find the region of all the area of all these. And as you see, it changes things a little bit because I have to do these two as separate regions, right? We'll call this one 1 and this one 2, because if you look at it, the first thing we graphed was y equals cosine of x, and that's this one. And the second one we graphed was the y minus cosine, 1 minus cosine of x, which is this one. So on region 1 and on region 2, the top curve is different. Now, again, for both of these, though, I still want to integrate with respect to x. Well, because you can see for two reasons. First of all, because I do not want to be integrating anything that looks like inverse cosine for sure, right? They gave it to us y equals cosine of x. So please, let's go with that, right? And then that is enough of a reason for me. The rest, I don't even need more reasons. If I'm avoiding inverse cosine, it's always a good day. So what I need to do though, I'm going to set my area integral here. I'm going to write it here over region 1. The top curve, it looks like that's cosine minus the bottom curve, which is 1 minus cosine x. And then on region 2, my top curve is 1 minus cosine x, and my bottom curve is just cosine x. Okay. So, I'm really feeling now that what I need, okay, is to figure out. So now I need to figure out, I know that this is 0 and I know that that's pi, but I don't know what that point is where they intersect. So now I have to figure out what that point is where they intersect, because I need to change this 1 and 2 into the right limits. So let's see. In order to do that, we're going to have to solve for it. So we're going to set the two things equal. Cosine x equals 1 minus cosine x. Okay, thankfully this is easy. About as easy a trig question we could have, right? So what angle theta or x gives us 1/2? And we know it's in the first quadrant anyway, because we're already looking for a point between 0 and pi over 2. So remember these all, this is a question as to whether it is pi over 3 or pi over 6. Let's see. So cosine is the x coordinate. If the x coordinate is shorter and the y coordinate is taller, it's going to be that. This is going to be 1/2. This is going to be root 3 over 2. And this x is going to be pi over 3. Is that right? cosine is, yes, I think that's right. Okay, perfect. Always double check yourself. Make sure everything is correct. Okay. So because remember cosine is our x coordinate there. I mean, it's a little bit irritating because yeah, x is here, but you get what I mean. You get what I mean. So from 0, and so this guy is going to be pi over 3, from 0 to pi over 3, and my second region is from pi over 3 to pi. Yep. Okay. All good there. Now let us go ahead and proceed to evaluate this integral. Now, we had to be real careful with the setup because they're different, right? Because this is 2 cosine x minus 1 on the first part, and then this is 1 minus 2 cosine x on the second part. They are similar enough that it's not like it's a lot of work, right? Because it's going to be the same thing, right? The integral of the derivative of sine is cosine. So this should be 2 sine x minus x. And then this one is going to be x minus 2 sine x. Evaluate. I'm sorry, I wrote the 2 at pi over 3. Pi over 3 to pi. Okay. Let me just go ahead and evaluate that. 2 sine pi over 3 minus pi over 3 minus 2 sine 0 minus 0. Yeah, we know that's 0, okay? But I'm writing it so because if it was cosine, it wouldn't be 0. So I have to be careful, to always be careful that I keep all my information sort of set up in the way that is good. Okay, so what is this? Sine pi over 3. Wait, we just did that. It was up here. I just wrote it out. It was 3 pi root 3 over 2, right? Because cosine is 1/2, sine is root 3 over 2. Okay, so this is 2 times root 3 over 2, 0 plus pi, minus sine of pi is 0. So then we have minus pi over 3 plus 2 times root 3 over 2. So this looks like I've got 2 root 3, and then pi minus 2 is going to be plus pi over 3. Yay. So basically, what we see here is what I've been telling you the whole time. You got to draw the picture. And then from the picture kind of tells you what you need to do. You can figure it out from the graphic. Without the picture, oh my God, it's really hard to tell what you're doing. Let's do another one. This one has an absolute value. So what does absolute value mean? As we all know, let's go over this. Absolute value is going to just be, where x is greater than 0, it's just going to be the same thing, right? And if x is less than 0, it's going to be minus x, okay? So I can write that like that if I want. Just remembering that absolute value is a piecewise function. Don't really need to do that if I don't want to. If I remember what it looks like, I don't need to do that, right? The graph at y equals x to the fourth just looks like a flatter parabola. And y equals absolute value of x, we know it looks like that. So minus is going to be turned over and added up to 2. So 1, 2, like right here. So that's gonna look like this. No, that's not great. Let me try. Make that a little bit nicer because it really should look more like that. Now, we're asked for the area of all of this. But this area is symmetric, right? There's the same amount on the left hand and the right hand side of 0. So I can either do it either way. I can do it from whatever this point is to that point, or I can do 2 times 0 to that point. Now, it usually doesn't make a big difference, but because I have absolute value here, absolute value is going to be defined differently on the left-hand side or the right-hand side of the axis. So I can significantly simplify my life if instead of doing from that point to that point, from here to here, I go from 0 to this point, which we're going to have to find out what that point is. I'm going to do that in a second, but just let me tell you where we're going with this first. So I'm going to do A equals 2 times the integral from 0 to whatever, right? And then I'm going to take the top curve minus the bottom curve. The top curve is the line, but that's going to be 2 minus x because that is the piece that we want. And then the bottom curve is going to be the curve, so that's x to the 4th. All right, let's label this a little bit better and go over that again so it's clear. Okay, so here I have chosen I have chosen to integrate with respect to x because I was given everything in terms of x, in terms of y as a function of x. So if I do my height as y2 minus y1, it's nice and easy. All right, so I chose that as my dx, so I just have to put that in. And I chose to use symmetry pretty much because if I had to, if I didn't, I'd have to still break it up into 2 pieces because this guy is actually broken up into 2 pieces, right? So how do I know which piece to use when I put this in? I put in the top piece because I'm only going from 0 to point whatever. And on that region, I have a positive x. So that's what's going on here. Okay, now the only thing that I need to do is figure out what the heck is my point. So let's look for this point here. Oops. Let's look for this point here. So I'm just going to do x to the 4 is equal to 2 minus x. Now I lost the absolute values because I'm specifically looking for this point, so I don't have to worry about the absolute value. I know on that part, it's this bit. All right, now this isn't great, right? Who chose this problem? If it was an x squared, I would be able to, use the quadratic formula or factor. With an x to the 4, I can't do anything. Like, I really can't do anything. So, what do I do? Well, I'm going to hope that whoever chose this problem had the sense to pick something easy. So, let's try just some guess and check. And of course, the easiest thing to try is 1. And it works. 1 plus 1 minus 2 equals 0. All right, I will tell you what, I don't usually do that on a test or a quiz. I would not expect you to be guessing and checking for solutions on a test or a quiz because that if I was a student, that would basically like cause a panic attack. So I don't want that for any of us. So if it was something like this on a test or a quiz, also that point might have been given. But on homework, you could also check it with a graphing calculator, find it that way. So various other ways of doing it, but this one, guess and check, that's an obvious point. So yeah. Now the rest of this, we just go ahead and integrate the usual way. This is 2x minus x squared over 2 minus x to the 5 over 5. Evaluate from 0 to 1. So this would be 2 minus 1/2 minus 1/5. Uh, so when is this? Seven, 13. So 13/5. That looks good to me. I'm good with 13/5. Let's look at one more. Oh, okay. This one's a little bit hairy. Maybe we'll make this one a separate video.